everyone tries to adopt the big data analytics approach in research as well as in policy analysis. These range of methods from most fundamental techniques, they range from most fundamental techniques that is descriptive, which involves preparing the data for subsequent analysis, to predictive analytics that provide advanced models to forecast and predict future, and to the top-notch analysis called prescriptive diagnostic analytics that utilize machine-based learning algorithms and dynamic rules engineers to provide interpretations and recommendations. Today, we see a lot of research based on this artificial intelligence, big data analytics, which try to provide different types of analysis, which are known as descriptive analytics, predictive analytics, diagnostic analytics, or prescriptive analytics. So data science technology is an umbrella term for a broad set of techniques to analyze and process huge amounts of data. For example, if you like to look at health data, you have different sets of data. People often do policy analysis based on a particular set of data, not necessarily integrating all the data or pooling all the data. If you take, for example, health policy making, people use survey data and analyze the survey data and do policy analysis based on survey data. There are others, they use clinical data, epidemiological data, hospital registration data, large amounts of data or experimental data. They use that data type of data for analysis and policy inference. But it's the best or the most holistic or the most effective way of policy making is to pool all of those data, for example, survey data, the registration data, or other secondary sources of data, including census or other types of registration data. If you are able to pool together, integrate them, and perform analysis, that type of decision making will provide very effective policy decision making. So today, data science, data analytics experts, they are able to collect data from different sources, and they pool together different sets of data and then integrate the data and perform what is called also triangulate the data and perform triangulated data analysis, which are very useful for policy analysis. A lot of policy decision in business organization, management organizations. So there's a large number of people who do big data analysis and analytics, use analytics, and they always give policy. They always regularly give decisions, policy decisions to the management. So data science is an umbrella term for a broad set of techniques to analyze, process large amounts of data. Data science has become increasingly important given that ever-growing volume and variety of data available today. Data scientists do not necessarily need a technical background, but more of a learning, extensive mathematical knowledge and experience to start with. If they have mathematical fundamentals and experience of working in modeling, then it is possible for them to deal with big data analysis. Not necessarily they need very strong early technical background. Today, people from different subject background, I think, try to learn this big data analysis, big data science methods, and they also try to use the models in policy analysis or for their research, policy analysis, policy research. However, the analysts need a good analytical skills and strong understanding of business analytics and principles and practice. According to a survey of more than 1,000 senior executives conducted by PwC, a highly data-driven organization, are three times more likely to report significant improvements in decision-making compared to those who rely less on data. So today, reliance on data, that is the most effective means of policy making globally in any sector, public sector, private sector, or any sector, social sector, health sector, economic sector, or service sector, whatever sector. Today, data-based decision making, evidence-based decision making, inclusive decision making, that is the hallmark of today's decision making. Data-driven decision-making, sometimes abbreviated as DDDM, is the process of using data to inform right policy decision-making process and validate a course of action before committing to implement that policy action. So that is the importance of the evidence-based policy making. So the whole of this lecture, policy analysis, the focus is on evidence-based policy making and how to use evidence, how to collect data, how the different data sources can be synthesized, analyzed to policy making. The data analytics methods to improve policy decision making in terms of the following components. The first I talked about earlier, the descriptive analytics. It's a branch of data science that focuses on analyzing large amounts of data to extract meaningful patterns, trends, or the data patterns. So once we are able to synthesize the data pattern, and it's possible to make a good inference of data for policy making. It's used to analyze behavior and characteristics of people, organizations, and the other entities. This is useful for business policy making or social or health policy making. Descriptive analysis is used to describe current state of affairs, things. The goal is to make predictions about what will happen in future based on current data. The next is diagnostic analytics. It is a form of data analytics that focus on understanding the system's current state and identifying all the factors causing it to perform poorly. So diagnostic analytics is the method that aims to identify all the issues causing a problem. It is in simple terms, if you deal with the health care, the first is somebody comes with a problem and then symptom, or the next is to do investigation to diagnose that problem, and the next stage is to make prescriptions for curing or preventing that problem. Diagnostic analytics aims, in that sense, diagnostic analytics aims to identify all the issues causing a problem, particular problem, such as where they might be occurring, what information is missing from the system, and how to resolve them. So that in clinical diagnosis, it provides all what is the problem and how possibly we can deal with that problem. Whereas predictive analytics is actually prescription or predictive, both are similar, is a data science branch that predicts future events. It refers to using statistical algorithms, mathematical models, or computer modeling to make predictions about future outcomes. Predictive analytics is a type of analytics that aims to anticipate future events or trends. The last is prescriptive analytics. It's very close to predictive analytics. Just once you have a problem, then you have a diagnostic and then a prescription. This prescriptive analytics is used to make better predictions. Prescriptive analytics is a field with data science that seeks to make predictions about consumer behavior, business performance, and more. Predictive analytics also a decision support system or statistical modeling. So these are about big data analysis, but the next the kind of technique or model used in policy analysis, very simple decision-making tools, which are known as decision-making tree or problem tree. These are, I mean, even when you perform complex analysis in terms of final decision, one has to think about stages of decision making, the way how to deal with decision making, the step schematic process of decision making. Maybe this is a kind of a tool that helps in decision making. So decision tree is a decision support tool that uses a tree-like model of decision and their possible consequences, including chance, event outcome, resource cost, and utility. So it's very clear that while you can always, any policy analysis may involve complex methodological analysis, operation research, or big data analytics, or other SWOT analysis, or many other types of analysis that we discussed in cost benefit analysis, cost effective analysis, whatever we may involve. Ultimately, there may be another stage of policy making where people may prefer to use a decision tree. Decision trees are commonly used in operation research and operation management. If in practice decisions have to be taken online with no recall and a complete knowledge, a decision tree should be paralleled by a probability model as a best choice model or online selection model algorithm. Another use of decision tree is a descriptive means and conditional probabilities. So if you look at, in last lecture, we discussed the quick analysis model where it can be combined with decision tree to make a policy decision. This is one of the ways to display an algorithm that only contains conditional control statements. Decision trees are commonly used in operation research, especially in decision analysis, to help identify a strategy most likely to reach a goal, but are also a popular tool in machine learning. Decision tree consists of three types of nodes. The decision nodes, typically represented by squares, chance nodes, typically represented by circles, and the nodes typically represented by triangles. So this is the chart that describes the decision tree, for example, to revise the budget. If you remember, if some of you, if you attended the last lecture, we discussed that quick analysis model. It is similar to this. For example, in this case, suppose there is a need or policy decision to make revise the budget for a city council or a big city council. The stakeholders involved and the policy decision steps involved in this shows the policy steps involved in terms of a quick analysis and decision tree. So there is possibly a budget commission which considers risk and risk alternatives. So the commission may or may not agree to revise the budget in view of risk alternatives. If there are no risks, the commission may approve the budget. If there are risks, the commission may not approve the budget. Then the next stage is the council, the city council, whether they approve or they disapprove. The council may accept or may reject based on what is the quick model analysis, which considers probabilities of four scenarios. Scenario one is that the commission budget on time that provides best consequences. And the second is mayor vetoes the budget delayed, so that is the third best consequence. The council returns the budget proposal, that budget is delayed, that is the fourth best consequences. And the council modifies and alternative budget, asks for alternative budget, that is the worst consequence. So the first is the council approves, the commission approves, and the mayor also does not veto, then that provides the best consequences with the probability of the positive success at 0.48. That provides the best consequences. This is how decision tree model is used in quick decision analysis. This is also an illustration of how does a decision tree work in actual implementation. The tree-based method apply if conditions on futures by doing orthogonal splits to build the decision regions. So within the decision across the spectrum, you can divide them into different regions or subsets, and then understanding how the splitting conditions are devised, how many times you need to split decision space is crucial to make a final decision. There's also something called problem tree. The problem tree is similar to the decision tree in my view, but I think there's differences in terms of the way it deals with the problem.